The difference between a hole and shaft-based system is whether or not, well, especially when you start fart designing. I did some fart designing this morning. I'm going to be posting 3 more assignments concerning tolerancing. These 3 assignments will heavily use Appendix A in the back of your text. Appendix A is a bunch of charts that list different types of fits and tolerances. The different types you can use to use these numbers to design whatever you're kind of trying to make. Does your part need to just slide together, or do you need them to make sure that 2 pieces can get located together and fit and function? Or I put that on backwards. Or is it just simply need to take 2 pieces and then force fit them together so they just stay together without any extra amount of fastening? I'm going to use page 1335 to kind of demonstrate how to use these charts and complete the assignments. I'm going to start with the second one on 1335 because the first one is just covering what I already did in the previous video. I'm going to swap over to a Excel spreadsheet I got set up here. So on number 2 here, I have a bunch of what looks like poop typed in here. That was supposed to be a tolerance here. Alright, so that is supposed to be LC2. Okay, so I have a basic size of 0.625, and then if you look at page 13.7, it discusses what RC, LC, and all those type of terms mean. RC is a running fit. That's where you have the parts that would, like I showed you there, where you'd have like a shaft and a hole that would have to slide together. The LC, LT, LN, those are your location fits, and then the FN are your force fits. So going to the back of the book, your Appendix A, I kind of have a mess of papers on mine. I'm going to find the chart that lists RC9, which is on page A3. And then I'm going to find on that chart, on the left-hand side, there is a list of ranges. So you're going to find the range that would contain your basic size. So in this case, I have 0.625, so I find 0.4 to 0.71. And then on that row, go over to the RC9 column. So and then on my holes there, I have a table value of 4 and for my maximum and 0 for my minimum. That 4 is these numbers are in 1,000th. So when you go to do your limits on this, you'll put in that value divided by 1,000 and then add on your basic size. And then this one is fairly obvious because it's 0, so I'll just set it to that. And then on my shaft, I have a tolerance of -6 and a negative for maximum, and then -8.8 for minimum. And then once again, I'll do this divided by 1,000, adding in my basic size. One more time. Adding basic size. You can do that in your head if you want, but you obviously can use Excel to do your math for you. LC2, same process. Find the chart that contains LC2, and then find the 0.65 in that range, and then fill out the rest. The assignment should have can't remember if I set it up for percentage or not on that one, but I'll have a thing over in the corner here that will auto grade as you fill it out. So if you do it correctly, this should start moving up, and then there should be something at the top that does a total score that also will be going up as you complete it. So I'm going to skip this next line for a second and jump over to the system. The system is referring to whether or not it is a hole system or a shaft system. When you're designing from the bottom up, determining whether you want a hole or shaft system, is a hole would be if you have a standard drill size that you're going to be using to create the part, and that'd be the hole system. Or if it's a shaft system, you had purchased a rod of standard size, and then it would need to fit a hole over the top of that. In this situation, what we're dealing with to determine whether or not this is a hole or shaft, we would pick whether or not this basic size is the minimum of the hole or the maximum of the shaft. So in this case, our basic size is the maximum of the shaft, so this is a shaft system. So it's like that. And then now coming over the IT grade, or the international tolerance grade number, we'll need to jump over to our appendix here, Appendix A, and now that we know that it's a shaft system, we can find up on each sheet, it should say shaft or hole basis. And I have, let's think here, I have a shaft, so I'm going to find a sheet that says shaft, and then looking at our basic size, find 2, and then you can see on page A12 I have a locational transition, and having matched up with those limits, I have a 2 for my max for a hole and 1.99 for a minimum of the hole, and yeah, so that matches up. And then looking up towards the top, I have a hole which has the number K7, and the 7, that's my international, my IT number. I'm going to type 7, and then I have an H6. The 6 is also the international number. So the K represents our fundamental deviation on the hole, and the lowercase h, represents the fundamental deviation of the shaft. It will always be uppercase for hole and lowercase for shaft. If you want to jump into the website you can download for this text and go to the tolerancing section, and then find exercise metric fit, to kind of run this down on what each of these things mean. So A is pointing here, which that's our basic size. The D is pointing at the H, which I just said that's our fundamental deviation. The E is pointing at the 8, which that's my international tolerance grade number. The B is pointing at my hole tolerance zone. And then the C is pointing at my shaft tolerance zone. So that's how to read that. Jumping back to my chart here, as I said, I looked at that and it was a locational transition, so my type of fit should be a transition fit. And then the last section here talks similar to what I did up here at 2. We are just gonna, reading the charts, we find an HK 7K6 in our appendix. H7K6, that's going to be a hole basis, locational transition. I have a basic size of 8. Find that on the left-hand column, and then just type in the numbers. So that's an 8.015, 8, and for the hole, and then for the shaft 8.0. Oops, in the wrong spot here. 8.010, and then 8.001. And I could fill out the rest. You just look through your charts, find what matches up with that, and fill it in. You'll be done. So this will all be for homework. In class will be, once you're done with your auxiliary views, you'll move into start making parts for assembly, which then will apply these tolerancing dimensions to those.